In this video, we're going to talk about derivatives. If we have a function such as f of x, we want to know the rate of change of this function with respect to its independent variables. And in this case, the independent variable is just x. If this function is linear, it's much more easier because a linear function is in form of y equal to mx plus b, and m is just the slope of the function, which is the rate of change of this function. So to know the rate of change of function y equal to mx plus b, we just need to calculate m. To calculate m, what we do is we take the change of y and divide it by change of x, which is y2 minus y1 over x2 minus x1. Okay, so we have an example. On the right side, what you have is a graph of a linear function. So let's find 2 points to calculate the slope of this function. The first point is from 0 and 1, so 0, 1. And the second point is 2, 5. So we have 2 points, 0, 1, and 2, 5. Now let's calculate the slope. M is equal to y2 minus y1. So y2 is 5, y1 is 1, x2 is 2, and x1 is 0. So it's equal to 5 minus 1 is 4. 2 minus 0 is 2, so it's 4 over 2 is just 2. We calculate the slope of this function, which is 2. And 0, 1 is just the y-intercept of this linear function, which is b. So we can also know the expression for this function, which is y equal to 2x plus 1. And we're done for linear function. But most of the time, functions are nonlinear, which means they don't have the constant rate of change. For example, on the right side, we have a graph of a function f of x equals x squared, which is a parabola. So the rate of change of this function is actually not constant. To calculate the average rate of change of this function is same as calculating the slope of the linear function. We take 2 points. For example, if we take 0, 0, and 2, 4, what we do is we connect them, use a straight line to connect them. So we form a secant line. So we get the secant line of this function. So the average rate of change over the interval delta x from 0 to 2 in this interval is just the slope of the secant line, which is the rate of change is equal to the delta y is 4 minus 0, and delta x is 2 minus 0. So it's equal to 2. If you want to know the instantaneous rate of change, which is the rate of change at a specific point, what we do is easy. We want to make sure these 2 points, the secant line, the interval, gets smaller and smaller until it almost reaches 0, but not equal to 0. That's why we use limit right here. Limit as delta x goes to 0 of delta y over delta x is equal to dy over dx. dy over dx is defined as the derivative of y with respect to x. We use limit because we don't want delta x to equal to 0, because delta x is the denominator, and denominator can't be 0. So that's why we use limit. Basically, what limit tells you is that we want quantity to approach a specific value, but not equal to that value. The formal definition of derivative is the limit at h approaches 0. We use h to represent delta x right here. And f of x plus h is y2, f of x is y1, so it's y2 minus y1 over delta x. As delta x approaches 0, that is the derivative of a function. Okay, so let's take a look at the first kind of function, x to the nth power. N is some real number. I don't know what that is, what this real number is. It can be 1, 2, or 1/2 or pi. No matter what that real number is, it always works. Okay, so now we plug in this expression into the definition of the derivative. Becomes x plus h, so it's x plus h to the nth power minus x to the nth power over h. X plus h to the nth power is just this is a binomial, so we can use binomial theorem to expand this expression right here. The typical binomial theorem doesn't work for any real number, only works for positive integer. But we can use another kind of binomial theorem called generalized binomial theorem. Generalized binomial theorem works for any real numbers. So we can apply, which means we can apply we can apply binomial theorem on n. By using binomial theorem, we can expand this expression to the following expression: x to the nth power plus n times x to n minus 1th power times h plus b times x to the n plus 2 minus 2th power times h squared plus a bunch of things contains some constant times x to some power times h to some power plus the last term, which is at h to the nth power, and we minus x to the nth power over h as h approaches 0. We have x to the nth power at here. We also have an x to the nth power right here. So they're cancelled. Okay, so for the leftover, all terms in the numerator all terms contain h. So what we do is we can cancel each h. Okay, we can cancel each h. This becomes n to the n minus 1th power. So the derivative becomes limit as h approaches 0 of n times x to the n minus 1th power plus b times x to the n minus 2th power times h, and blah 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 plus h to n minus 1th power. What is the middle? This expression is all contains h, and we have already eliminated the denominator, so we can plug in h equals 0 for this expression, which means this is equal to 0. So the dy over dx, if y is equal to x to the nth power, is just equal to n times x to the n minus 1th power. All right, so let's take a look at example. This function is the function we have seen before in the last slide. So by using this expression, we can find the derivative of this function. N is equal to 2, so the derivative should be 2 times x to 2 minus 1th power, which is just 1, which is 2 to the 2x. The derivative is just 2x. If we take the derivative of this function, of the y, which is the second derivative of this function, dx of dy over dx, which is also equal to d square y over dx squared, is equal to 2, because remember, this is a linear function. The rate of change of linear function doesn't change, so is equal to the slope of this linear function, which is equal to 2. Now we need to know some rules for computing derivatives. The first rule is called, actually this rule is the most important rule that we have seen before, power rule. D dx of x to the nth power, if n is some real number, is equal to n times x to the n minus 1th power. And these three rules, except the power rule, are the most important rules. Constant rule. If the derivative of some constant times a function is just equal to the constant times the derivative of the function. And some rule tells you that if the derivative of a sum of two functions is just equal to the sum of the derivative of each function. So in this case, it's derivative of f plus g is equal to df over dx plus dg over dx. Different rules is the same. The ddx of f minus g is equal to df of over dx minus dg over dx. And remember, the f and g are both functions of x. And next one is product rule. It's not quite important, but it's still useful. ddx of f times g is just equal to df over dx times g plus dg over dx times f. If these two functions are vector valued functions such as a and b, then ddx of a dotted with b is equal to dA over dx dotted with b plus dB over dx dotted with a. The ddx of a cross with b is just equal to dA over dx cross with b plus dA cross with dB over dx. And the last rule is called chain rule. We use this rule to compute the derivative of a composite function. For example, if we have a composite function f of g of x, g is independent. Sorry, f is independent. X is independent variable of g, and which is the independent variable of f. Then the derivative of f is just equal to df over dg times dg over dx. We take the derivative of the outer function with respect to the inner function, and then we take the derivative of the inner function with respect to the independent variable x. That's the chain rule. All right, so let's do some practice. You can pause the video and try that on your own. To get the answer, let's do that together. Y is equal to 2x cubed plus 4x plus 8. So we should use sum rule first. dy over dx by using power rule and constant rule. That derivative 2 times the derivative of x cubed, which is equal to 3x, 3 minus 1 is 2, so it's 3x squared, 2 times 3x squared, plus 4x is linear, so it's just 4. We take the slope of this function. And 8 is a constant, it doesn't change, so the derivative of 8 is just 0. So the derivative of y with respect to x of this function is equal to 6x squared plus 4. The second function is y equal to square root of x squared plus 3. So the dy over dx is just equal to, remember, square root is 1/2 power. So the square root, so the derivative of y with respect to x is just 1/2. We take 1/2 down, 1/2 is equal to n. And n minus 1 is 1/2 minus 1 is negative 1/2. Negative 1/2. But remember, we're taking the derivative with respect to x squared plus 3, not x. So we need to take the derivative, which is dg over dx, with respect to x. Take derivative of x squared plus 3 with respect to x, which is 2x. We multiply by 2x. 3, the derivative of 3 is 0, so it's just 2x. 2 and 2 are cancelled. So this derivative is just x over square root of x squared plus 3. That's the answer for the derivative of this function. The third function is the same as actually that's really similar to the second one. If you want the way of taking derivative of third function is really similar to the second one. What you do is convert that to the form like that. 1 over 1 plus x squared is just equal to 1 plus x squared to the negative 1th power, negative first power. So the dy over dx is that n is equal to negative 1. So it's negative 1 times parentheses 1 plus x squared. Negative 1 minus 1 is negative 2 We're using the chain rule, so we need to multiply by the derivative of 1 plus x squared, which is 2x. So the derivative of this function is negative 2x over 1 plus x squared. Hopefully that will be helpful to you. Thanks for watching and have a great day.